Okay, today we're going to go over CC1 511 review and preview. So the first problem is problem number 4, and that says that the diagrams below show the portion of another class mural that Josephine was supposed to paint and how much she actually did paint. Use the pictures to answer the questions that follow. So the first picture was the portion that Josephine was supposed to paint. And the second one, let me get my pen. The second one over here is the portion that she actually finished. So if I look at this whole mural, okay, so for part A, it's approximately what portion of the painting was Josephine supposed to paint. So I am looking for part A, I am looking at this painting here. Now, she agreed to this, and if I just draw some lines here, well, she agreed to about a quarter of the mural, okay? Now, of what she agreed to do, so again, if I go for part B to this side, okay, it says, well, what did she actually complete? And this is what she actually painted. Well, she agreed to do this whole section here, but she only did half of it. Okay, so she did half of what she said she'd do. Now, the key word here is half of what she said she was supposed to do. So it's 1/2 of, and remember, of is multiplication, 1/4. That's what she agreed to do, which means that if I were to change and make all of these sections into halves, well, she did 1 out of 1, 2, 3, 4, 5, 6, 7, 8, which is what we've been doing in class. So that 1 out of 8, well, that's what she did. That's what she actually painted. 1/8 of the whole thing. Okay, moving on to problem number 5. Draw a rectangle with a width of 8 units and a length of 6 units. So I'm going to draw a rectangle. It's going to be, no, I did something wrong there. We'll erase it. This is 8 and this is 6. Okay. Well, if this rectangle here got enlarged, and instead of 8 by 6, it became 16 and 12, well, what is the enlargement ratio? Well, if I go from 6 to 12, I multiply by 2. 8 to 16, I also multiply by 2. So the enlargement ratio of new to original is 2 to 1 because I could write it this way. And the reason I know it's that is because we multiplied by 2, and this number right here is 2. Now, if I want to reduce the 8 by 6 rectangle, and it's a ratio of 1/4, okay? In this case, in part A, I multiplied by 2 to get the enlargement. To get the reduction, I'm going to multiply by 1/4, okay? Now, when I multiply by 1/4, we've been talking about, we might know how to do this already. Multiplying by 1/4 is the same thing as dividing by 4. Okay, so my original is 1 to 4. It's going to get smaller. We know it's a reduction. So, again, we have my 8 by 6. I'm drawing it here for a reason. I have to multiply all the sides. So the 8 and the 6. That's what I like to do. 8 times 1/4 and 6 times 1/4. That's going to get me my answer. Now 8 is 8 over 1 and 6 is 6 over 1. So we can't forget that all whole numbers have a 1 underneath them. We multiply straight across. 8 times 1 is 8. 4 times 1 is 4. This is the same thing as saying 8 divided by 4, which is 2. This one, 6 times 1 is 6. 1 times 4 is 4. 6 divided by 4. Well, that's going to get me a decimal, but if I don't do that and I want a fraction, I can look at this fraction and say, well, 4 goes into 6 one time. I'll have 2 out of 4 left over. 1 2/4 is the same thing as 1 1/2. So the dimensions are going to be 2 and 1 1/2. Okay, moving on to the other side. Problem number 6, we're going to recall the definition of absolute value. That is the distance away from 0. So for each pair of points below, find the distance between the given points. Show your work using absolute value symbols. When I do this, I'm going to be given 2 coordinate points, which is what you can see in A and B. I know that there's an X and a Y in both. So looking at part A, I have 13, 14 and -3, 14. I'm going to look at my X's and my Y's and figure out, well, which ones are different. In this case, my Y's are both 14, but my X's are different, and so I'm going to circle them. The reason I circle them is those are the numbers that I'm going to be working with. I have to use absolute value symbols. So it does not matter which order I put them in. I just go with the first coordinate point first. I have 13 minus -3. So I have the -3 and I have the 13. That's what's from my coordinate points. I always subtract them. Well, this opposite and this opposite create an absolute value that really is 13 plus 3. Well, 13 plus 3 is 16. The absolute value of 16 is 16. That is my answer. For part B, I have -9, 1 and -9, 11. In this case, the X's are the same, which means that I am going to be working with my Y's. Just to prove a point with it doesn't matter which order you put them in, I'm going to put the 11 first and the 1, and I'm going to subtract them. And right below it, I'm going to do the 1 minus 11. Okay, because they're both positive coordinates. Well, 11 minus 1 is 10. So the absolute value of 10 is 10. They are 10 apart. I could do 1 minus 11, which is -10. The absolute value of -10 is 10. They're 10 apart. That is my answer. So just remember that we're working with the coordinates that are different. Moving on to the next one. Change each fraction greater than 1 to a mixed number, and change each mixed number to a fraction greater than 1. Essentially, part A is going to look like part B, and part B is going to end up looking like part A. To do this, I have to take my whole number and multiply it by my denominator and add my numerator. So 4 times 5 is 20, plus 4 is 24, and I keep the same denominator. I'm going to skip over to C. I know it's out of order, but we're doing the same process. So the whole number times the denominator add the numerator. 4 times 15, well, I can count by 15s. 15, 30, 45, 60. Plus 13 is 73, and it's over 15. That's my answer. 17/7, I'm going to basically 17 divided by 7. 7 goes into 17 2 times, which is 14. I have 3 left over. That would be my remainder. But the cool part is, I know it goes in 2 whole times. I have 3 out of 7 remaining because that remainder is now my numerator. Same thing here, 68 divided by 3. 3 goes into 6 2 times. 6 minus 6 is 0. Bring down the 8. 3 goes into 8 2 times, which is 6. There's 2 left over. Typically I'd go on, but because I'm going to a mixed number, I can say, well, it's 22. This 2 becomes my numerator, and the 3 stays as my denominator. Last problem. Simplify each of the following expressions. Be sure to simplify each of your answers as much as possible. Write any answers greater than 1 as mixed numbers. So, 3/5 plus 1/4. The key is to have a common denominator. 5 and 4. Well, if I count by 5s, 5, 10, 15, 20. And then 4s, 4, 8, 12, 16, 20. 20 is my common denominator. So I always rewrite my problems. 3/5, if I use a giant 1 to make a fraction out of 20, it's 5 times 4. 3 times 4 is 12. 1/4, I do the same thing, although this time to get to 20, I have to multiply by 5. 1 times 5 is 5. 12/20 plus 5/20 is 17/20. For part B, same steps, this time I'm subtracting. So I have 4 and 3, 4, 8, 12, 16, 3, 6, 9, 12, 15. 12 is the common denominator. 3/4, use a giant 1, I have to get to 12. 4 times 3 is 12, 3 times 3 is 9. Do the same thing with 2/3. 3 times 4 is 12, 2 times 4 is 8. 9 minus 8 is 1, and I keep my denominator. For part C, I really want to make these into improper fractions before I start, and it's just a good rule of thumb because it helps us with subtraction so we don't forget the steps. So 5 times 2 is 10, plus 1 is 11. 4 times 3 is 12, plus 1 is 13. Oh, that's supposed to be a 3. The denominator is not 2. We'll just fix it. Okay. 2 and 3. 2, 4, 6, 8, 3, 6, 9. 6 is my common denominator. If I take 11 halves and I get a denominator of 6, I have to multiply 2 times 3. 11 times 3 is 33. 13/3. 3 times 2 is 6. 13 times 2 is 26. 33 plus 26. 6 plus 3 is 9. 3 plus 2 is 5. This is 59/6. Or I could figure out the mixed number. 6 goes into 59 9 times, because that's 6 times 9 is 54. 59 minus 54 is 5, so it's really 9 5/6 if I put it into a mixed number. On part D, I multiply fractions straight across. 7 times 5 is 35. 8 times 6 is 48. That is my answer. As always, if you have any questions, please feel free to come and talk to me in class, either before school or on a Friday, or before class if you get there early. Thank you.